Hello everyone, I am Paresh Mishra and here I am going to present my project on IOT solution to fulfill the partial requirement of AIOT goals. Here I have used Thingspeak for the analysis and prediction on my dataset. Thingspeak is an open IoT analytics platform service that allows us to aggregate, visualize, and analyze live data streams in the cloud. ThinkSpeak is often used for prototyping IoT systems that require analytics. So let us begin. So here I have chosen a public channel with the name of air quality with SD as 011 and channel ID 357142. Here we can see that these are field of datasets. Field 1 is air quality PM 2.5, field 2 is air quality PM 10, field 3 temperature, air pressure, humidity, controller temperature and sensor time offset. To understand your dataset in a better way, we can see it in a tabular format. Here we can see that first the timestamp is noted at which the data was recorded, then the next column is entry ID, then field 1 corresponds to air quality PM 2.5, field 2 corresponds with air quality PM 10, field 3 corresponds with temperature, field 4 with air pressure and so on. So now to start, I have created my own channel with the name of AIOT air quality, and my work on this project is clearly represented with these visualizations. To understand it better, let me take you to the MATLAB analysis part. So first of all, I have cleaned my entire dataset, as the dataset I have received and retrieved from Thingspeak channel contains some missing value. So the data is cleaned of the missing values using a list-wise deletion algorithm. List-wise deletion algorithm excludes the entire data entry if there is any single missing value present in it. And then I route the entire clean dataset back to my own Thingspeak channel. To understand the MATLAB code better, we can see that here I have specified the read channel ID to specify the channel to read data from. So this ID is same as our public channel ID 357142. Then I have specified the channel read API key, which is the read API key of my own channel AIOT air quality. Then I have specified the write channel ID as my own channel ID, and then write API key of my own channel. Then I have used Thingspeak read function to read the data from that channel, and the number of points I have chosen the 10 air quality data points from that air quality channel, and then stored it in in the form of AQI data with the timestamp. Now we will check for missing values. Missing values are generally represented with NaN values, so we can use the function isNaN to find the NaN values in the returned array. To quickly identify if NaN values are present in the data, we can sum the result of isNaN function. So we have here we have summed the data of isNaN function from that AQI data, and then stored it in variable any missing values with the name any missing values, and then we have used the logic that if any missing values are present there, then the value of any missing values variable will definitely be greater than 0. So then we find the indices of rows with missing values. with the by using the function find, and then we selected only the rows that do not have any missing values, and then stored it in as clean AQI data. Then we select the appropriate timestamp, as the entire row or entry will be removed from analysis if any single value is missing. So the clean timestamps contain the timestamp of uh, uh, of the entries which do not contain any missing values. And in the else part, uh, like if there's no missing values in the data entry, then it simply stores it in the clean AQI data and timestamps. And then I have displayed it and routed it back to my own Thingspeak channel. So let us see. Here you can see that this is my clean data. I have chosen only 10 entries to be displayed. So these are my 7 fields. Field 1 corresponds to air quality PM 2.5, field 2 corresponds with air quality PM 10, and then it is temperature, then it is air pressure, humidity, and so on. Now let us see the second analysis that I have done. I have calculated and displayed the average air quality. So I have here calculated and displayed the average air quality of last 120 hours from the channel. So here I have specified the read channel ID, same as previous 357142, and here you can see the air quality field ID is 1. I have chosen air quality with PM 2.5, so its field ID I have specified here, and the read API key is here, and then I stored the data which I have read from the channel in as air quality. I will specify the 120 hours as 7200 minutes, and then I have calculated the average humidity using the mean function present in MATLAB and stored as AVG air quality. Then I have specified the write channel again like API key to write back the average calculated here in my own channel. So let us see. As we can see here that average air quality for past 120 hours is 3.9467. Now the next analysis I have done here is calculate minimum and maximum air quality for last 24 hours. Same as previous, I will specify the read channel ID and air quality field ID and then read API key, and then I read the data from the public channel and stored it as AQI with the timestamp. And I have taken the data only for last 24 hours, so only for 1 day. And then I calculated the max and min of that data AQI, and then stored it as max AQI with max AQI index and min AQI index. And then I calculated the timestamp using the index value I have got here and stored it as time max AQI and time min AQI. Then I simply displayed it, the max AQI and min AQI, and wrote it back to my own channel. Here I have not written it back, but we can do so. We can see that the maximum air quality index PM 2.5 for the past 24 hours is 12.7000, and minimum air quality index PM 2.5 for the past 24 hours is 1.1. So this was my analysis part. Next, we will see the visualization part. Okay. So here I have done several tasks. First, I have visualized the correlation between temperature and humidity data retrieved from the public channel. So to see in the MATLAB code, here I have specified the read channel ID and temperature field ID. Here the temperature field ID is 3, so I will specify here, and then humidity field ID is 5, and the read API key, and then I use the function Thingspeak read to read the data. I have taken 300 data points to analyze this correlation, and then I stored the temperature data in this variable and humidity data in this, and then I plotted the scatter plot between the temperature data and humidity data to understand the correlation between temperature and humidity variables better. So now let us see what happens. Here we can see that the scatter plot between the humidity and temperature for last 300 increase, and we can see here that there's some relation, some correlation exists between the humidity and temperature. We see that as the temperature increases, temperature rises, the humidity value falls down. So here we can see the inverse relation between the humidity and temperature, and this relation definitely will help us later in the further analysis. Next, I have compared the air quality data from 3 different days. So first, let us understand the MATLAB code before proceeding. So here I have read the data from the Thingspeak channel for 3 separate days, and here the read channel ID is this, and air quality PM 2.5 field ID is definitely 1, and then I have like declared the 1 day time range, and then the API key, and then I calculated and retrieved the data from the channel for 3 different days, day 1, day 2 and day 3, and then create the array of duration, like the duration of the data, the duration of retrieval of data, and then to visualize the data I have plotted it. So let us see. So we can see here that blue line is for day 1, red line is for day 2, and this orange line is for day 3. So as we can see clearly from here that generally day 2 had the worst air quality, and at the 100th minute air quality of day 3 had a peak, we can see here, and there's a simple analysis between 3 days air quality. So we here by using this function, this uh, program, we can have a simple comparison between 3 days, like and then can observe the real cause between the rise or fall in air quality. So here I can see that Initially, the gate 2 had the worst air quality, like highest air quality, uh, with the PM 2.5. It even reached the value of 15, whereas at the same time, the day 1 air quality was only near the, I guess, 2 or 2.5. So this is a simple comparison between the air quality data of three different days, three consecutive different days. Next, I have plotted the temperature and air quality on two different y-axes. So to visualize the data better, I have plotted it on the two different y-axes. Like I have first specified the read channel ID and the read API key. The temperature field ID is 3, air quality field ID is 1, and then I simply retrieve the data and store it as data and time stamp. I have like collected 400 entries, and then I'll store the temperature data in this variable and air quality data in this variable, and then I try to plot the data to visualize it better. So let us see. So here the blue line shows the temperature and the red line shows the air quality with PM 2.5. So this data is between 4th May and 8th May. Uh, the data is mostly from the 7th May till the 7th May. So here we can see that from 4th May to 7th May we can observe a relation between the temperature and air quality as well, which can maybe help us for the further analysis. We can see that as the temperature rises at any part, we can see that as the temperature rises, the air quality value falls. With the temperature at its peak, the air quality value is at its least. As the air quality value rises, the temperature value decreases, and at the peak of the air quality, temperature is as its minimum, and at the peak of the temperature, air quality value is at its minimum. So we can obtain a relation between temperature and air quality value as well. Next, I have used a histogram to understand the variation in air quality data to see the MATLAB code. Read channel ID is this, air quality field ID is 2, read API key, and then I've decreased the data and stored it as a QQI variable, and I have chosen it for last 10 hours, that is 10 into 16 minutes, and then plotted a histogram using this histogram function of MATLAB. Let us see the histogram here. We can see here y-axis denotes the number of measurement for each air quality rating, and the x-axis is simple air quality with PM 2.5. We can see that air quality rating is varies from value 2 to 14, and the most of the measurements of air quality rating, the most number of times the reading was around 18. The reading was air quality reading was between 4 to 6 or 6 to 8. It lies between 4 to 8 most number of times, and the number of measurement is 18. then it is between 2 to 4 for 7 number of times, and then for the 5 number of times it is between 8 to 10, and then 10 to 12 and 12 to 14 for only one time. So we can so from here we can observe that for the most of the time our air quality reading lies between 4 to 8. Next, I have used the machine learning concept to predict the air quality. Here I have retrieved the data and stored it as data variable, and I have taken 720 minutes. Okay, and let me make you clear that this public channel collects reading at once at every 12 minutes. As we can also see this here, that at every 12 minutes once the data set is updated. So every entry is recorded in the time interval of 12 minutes. So let us see. Yeah. So here to predict the data, I have used the auto regression model. So auto regression model is simply forecast the variable of interest using a linear combination of past value of the variable. The term auto regression indicates that it is the regression of the variable against itself. So here I have used AR model. So like we can see here that first we have tried to get the trend of the data, and then we use the function dtrend. What the dtrend simply subtracts the mean or the best fit line from the data. If the data contains several data columns, then dtrend treats each data column separately and it removes a trend from the data, which enables us to focus our analysis on the fluctuations in the data about the trend. And then I will specify by my model order as 8. Then I have used the AR function. AR is nothing but auto regression, and let me tell you what the AR function does. AR function simply uses the algorithm specified by approach, and it uses the AR ID poly model sys of order this model order, and their model properties include covariances and estimation goodness of fit. And I have taken number of sample as 100, and then I have used the forecast function of MATLAB. Forecast function simply forecasts the output of an identified time series model sys, and it forecasts the value for the number of samples that I have specified here. Let us say this is k, then it forecasts k steps into the future using past measured data. Okay, then I have recreated the data here, and then to plot I have simply given the upper bound and lower bound by using id data function. Id data function creates an object for time series data, and the object contains a time domain output signal. We can see this is a output signal and an empty input signal. and TS is nothing but the sample time of experimental data. So I have specified upper bound and lower bound for the difference of plus minus 1 standard deviation, and then plotted the data, and then plotted the upper bound and lower bound with a dotted line. So here I can see, yeah, here it is. So the red line is nothing but the measured value of air quality, blue line is the forecasted, and the dotted line is the uncertainty range of that forecasted value. It is nothing but plus minus 1 standard deviation of the forecasted value. So we can see that till here it is measured, and after that it is like becoming constant for the future uh, time interval, and it is around 4. So here I have also done prediction using the AR model, and that's it from my side. And to view all the visualization and all my project work at one place, we can see here on the dashboard. So this is like my field 1 air quality PM 2.5, this is field 2, this is temperature, then air pressure, then humidity, controller temperature, then sensor time offset. Then I have like visualization correlation between temperature and humidity, then histogram of air quality variation, then 3-day air quality comparison, then the temperature and air quality plot on two different y-axes, and then prediction of air quality for the future values. That's it. Thank you everyone, and stay home, stay safe. Thank you.